Welcome to Marine Tech Talk, a podcast about how Teledyne Marine's innovative technologies are enabling scientific discoveries and commercial tasks in the world's oceans and waterways. On this episode, we're joined by Roy Forsyth from Collins Engineering. Roy is a professional engineer registered in 20 states and a National Society of Professional Surveyors certified hydrographer with over 19 years of experience in the industry. He is a commercial dive supervisor certified by the Association of Diving Contractors International with bachelor's and master's degrees in structural and geotechnical engineering. Roy leads Collins Engineers' acoustic imaging program by providing in-house training sessions and developing systems and processes for uniquely challenging projects that arise. Here's Roy Forsyth with the host of Marine Tech Talk, Melissa Rossi.
Roy, you're a structural engineer and commercial diver for Collins Engineers. Can you tell me a little bit about what your company does and where they're located?
Yeah, so the company Collins Engineers was founded in 1979 by Tom Collins, and we've got our headquarters in Chicago. He sort of founded the company based on the idea of using commercial divers who were also structural engineers to perform underwater inspections. And that's where he got his start. He also did a lot of structural design at that time. And since that time, the company has grown to 25 offices nationwide, about 260 employees. And with last roll call, we had 71 engineer commercial divers on staff, which I think is probably more than any other company probably in existence. So since that time, we've become a full service civil engineering firm, do anything structural and civil engineering related. And we still have a very strong undertaking in the underwater inspection industry as well, obviously, which is primarily what I do.
Okay, so what actually do you do for them? So you're a structural engineer and a commercial diver. What's your role within the company?
So I lead a small group of underwater inspectors. Primarily, we do other things as well, primarily structural inspection related, but the bulk of my work is all underwater related. And then I oversee the acoustic imaging program for the majority of our people as well, which is where we get into a lot of work with the BlueView Beebe 5000, as well as some other devices out there that we find that work well for us. But we've got a kind of a soft spot in our heart for the Beebe 5000, the Teledyne product. So.
Well, that's nice. We're glad to hear that. Actually, that's how we got connected. A colleague of mine saw a video you had posted. It was a data video made with the BlueView Sonar data, the BV 5000, and then she referred you over to me so we could have a chat and hopefully get you on the show. Could you tell me a bit about that data collection? If you can tell me about the job you were on, or certainly how you created that data, that'd be interesting.
So the job you're referring to that you saw the video for, we actually just won a RTNS Railway Track and Structures magazine best use of technology for railway projects. And we were awarded that for our use with the BlueView 5000 as part of this project. But it was a railway project where they had extreme flooding that tends to cause scour on a real old bridge that they have. And so we were there just every day scanning in the water where divers can't safely enter. It was about 13 foot per second currents. But we were able to safely dip a sonar in the water and get a look at what's going on with the bridge foundation on a daily basis. And so last year we spent, I think it was around 43 consecutive days scanning the same bridge over and over, letting them know what was going on and giving them recommendations for repair to keep it in service throughout this flood event.
So is that when do you always use the BlueView Sonar when you're doing that type of work, or does it depend on the currents and whether it's safe for divers? Are there times you put divers in the water instead?
So, I mean, as a commercial diver, I think my number one go-to is usually sending divers in the water. But I'm not naive enough to think that there aren't certain areas that can be better done or more safely done by technology and by sonar. I think we first gravitated to the BlueView sonar really for its ability to operate without GPS. And that was kind of a result of our usually being working in areas with heavy canopy, like under low bridge decks, things like that. And it also, I guess I'd say, added the extra benefit that because it's not fully georeferenced, it doesn't have motion compensation. It also doesn't have the extra cost that goes along with those aspects. And a lot of times cost is a big issue for a lot of our clients. So that's really what drove us to the BlueView. We do use some other sonar as well from time to time for these type of activities, but if the 3D data is of benefit, that's usually going to be our go-to product.
Is that why you originally chose the Beebe 5000? Was it that 3D scanning data that you were able to capture with it?
Right. Well, I mean, there's a number of other devices out on the market that can do multi-beam data collection. It's really just a multi-beam is all it is, but there aren't a lot of products on the market that can operate independently of or without GPS data or without motion compensation. So yeah, that's a big part of what drove us to this, is that ability to operate it without GPS. So.
And how often do you end up deploying that, or how many jobs do you do typically in a current month? I don't know if things have changed, of course, because of the environment right now, but...
You know, it really varies. Like I said, we were on that one job for 73 days total, using it literally all day, every day last year. I think we purchased our first Beebe 5000 sonar in 2012 or 2013. We wore that one out, and since that time, we've purchased 2 additional ones. So one really unique project that we did get into, and we can post some video fly-throughs from this as well, kind of outside our normal realm, but it was for the Indiana DNR, and it was documenting a bunch of shipwrecks on Lake Michigan. You know, we used traditional multi-beam sonar to collect the main portion of the data, but then we were actually able to send divers down with the Beebe 5000 and have them enter the hulls of some of the ships and get interior data. That turned out pretty neat as well. We can post some of that on there for viewers to look at as well.
You mentioned that your team will use the sonar when it might be too dangerous to put divers in the water. Safety has to be an important consideration for you and your team. When else would you defer to using the sonar?
Yeah, so there's a couple of other areas that are really my go-to areas for using sonar and the BlueView in specific. One project that we recently completed for Alabama DOT was a 200-foot deep bridge. It's called the Duncan Bridge. And to dive at those depths is very unsafe for a diver, dealing with decompression and limited bottom time, things like that. And this particular site has a lot of standing timber debris for entanglement at the channel bottom. So it's just a real unsafe situation for divers. And so the approach that we came up with was to lower the BlueView to the bottom, which normally the BlueView, the Beebe 5000 sonar, only operates up to about 150-foot cable length. So we actually custom built a Ethernet extender and had it installed into a subsea bottle, and then we had a custom cable made so that we could push the signal of the BlueView 5000, Beebe 5000 down to the depths that we needed to image the foundation and make sure that this bridge foundation wasn't undermined. And the project turned out to be a really big success. And I actually wrote a big article about this project that's also posted on LinkedIn. I can shoot you an image to that, or a link to that, and there's a video on there as well. Another area that we use it a lot is just to document very complex details. Most of our work is in inland waterways, usually very limited visibility, and usually photographs and video underwater don't work out very well. And so a lot of times it's just easier to have a sonar take an image so that you can show a client what it is that you're trying to describe, rather than have a diver spend all day trying to document some real complex detail that you're finding underwater. So.
Yeah, and for listeners out there who haven't seen the data images that Roy and his company have created with the Beebe 5000 sonar, we'll send the links, or we'll show you links to it, but it really is like a picture. I mean, it is 3D imaging. It's amazing. The video that we saw on LinkedIn not only had the substructure, the under the water part of the structure, but you were actually able to see the top part of the bridge in that. How did you do that? Because that definitely wasn't the underwater sonar part.
Yeah, so for the Duncan Bridge video fly through, the above water portions were completed with an aerial drone and with something called photogrammetry. So all it is the drone takes a whole bunch of pictures from all different angles, kind of does a pattern fly through, and then there's some computer software that you can run that through. Basically, it'll create a 3D model of the above water portion that we can slap onto our below water BlueView 5000 information and just kind of complete the picture, let people get a better understanding of what it is that they're looking at and where it lies in the real world. So,
is it just your team that uses the sonar, or are there other teams within Collins that do that work?
It's primarily our team, but I'm building up people around the nation that are also trained at this time. So we've got a number of people that are taking advantage of it in other offices as well now.
And you mentioned to me, I think when we spoke previously, when we were getting ready to have this call, that you are doing work internationally as well?
We do occasionally. We used to have an office in Ireland that has got closed down just based on some of the economy in Ireland. The workload wasn't really there anymore. Got closed down a few years ago. But we do a lot of work for the U.S. Navy, and that gets us to a lot of military bases that are literally all over the world. Most of our clients are state DOTs, so that's our normal client is underwater bridge inspections around the country. But we get into a handful of other unique situations, and we're consultants, so literally pretty much go anywhere anyone is willing to pay us to go. So,
besides bridges, what other types of structures do you inspect with the sonar?
So, I mean, literally anything that gets built on the water. So, it could be bridges, dams, shipping piers, and other port facilities, pipelines, seawalls or dock walls. You name it, if it's built in or under the water, we'll do structural inspections for it.
Well, thank you. I really appreciate you taking the time today to chat with us, and let us know if you need anything else in your work, okay?
Okay, will do.
Thanks.
Thanks for listening to the Marine Tech Talk podcast. A link to the Duncan Bridge data discussed on today's show and the reference post on LinkedIn can be found on the Marine Tech Talk website in the notes for this episode. We'll also put a link in the episode notes to the Collins Engineering website and the company's Twitter and Instagram accounts so you can learn more about the company. If you have any questions or comments about this show, you can email host Melissa Rossi at marinetechtalk@teledyne.com. If you like this podcast, please make sure to subscribe on Apple Podcasts or wherever you're hearing the show. That way, you'll never miss an episode. Thanks for listening. We'll see you again next time.